This is Dr. P. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about test of hypothesis for single mean. So, what is test of hypothesis for single mean? So, before going to start test of hypothesis for single mean, so first of all, how many methods are there in large samples? So, these are all large samples, right? So, that's why. So, first we will discuss about how many large samples are there. Okay, so how many tests are there in large samples? Okay, so first one is test of hypothesis for large samples. Okay, there are 4 tests are there for large samples. So first one is the test of hypothesis for single mean, and second one is test of hypothesis for difference of means, that means double means. Next one is test of hypothesis for a single proportion, and test of hypothesis for difference of proportions, that means double proportions. So first we will discuss about test of hypothesis for single mean. Test of hypothesis for single mean. So here we have only one mean, but that means here we have to take only one samples from the population. So here we have to take only one sample from the population. So let us check the test of hypothesis for single mean. So consider a sample of size n. Consider a sample of size n with mean x bar. That means which mean? So that is sample mean. The sample mean is x bar from the population with mean. That means population mean is mu, and the population and standard deviation. The population standard deviation is sigma. Then the test statistic z is given by. The test statistic z is given by z equal to x bar minus mu by sigma by root n. Okay, so here the population, we know that first you remember these points. Population size is denoted with capital N, and the population mean is denoted with mu, and the population variance, so that is denoted with sigma square, and the population standard deviation that is denoted with sigma. So like that, coming to sample. Okay, so this is population. Okay, population, and coming to the sample. So sample size is denoted with small n, and the sample mean is denoted with x bar, and the sample variance is denoted with s square, and the sample standard deviation that is denoted with s. Okay, so remember these 4 and these 4, totally 8 points. Okay, so after that, consider a sample of size n, and sample mean is x bar from the population mean mu, and standard deviation is sigma. Okay, so then the test statistic, that means our formula in test of hypothesis for single mean is z equal to x bar minus mu by sigma by root n. So if they give sample standard deviation instead of sigma, if they give sample standard deviation, we need to write s. Okay, so that's why that will be z equal to x bar minus mu by s by root n. Otherwise, you can consider sample standard deviation is equal to population standard deviation. Okay, so but sometimes they will give z equal to x bar minus mu by sigma by root n. Sometimes they will give population standard deviation, and sometimes they will give sample standard deviation. So most of the cases they will give sample standard deviation only. Okay, so next we have a confidence interval for single mean. So confidence interval is possible only for the single sample. Okay, single sample. Okay, so consider confidence interval. The confidence interval formula is here x bar minus z alpha into sigma by root n, comma x bar plus z alpha into sigma by root n. So x bar minus z alpha into sigma by root n, and also this can be written as x bar plus r minus z alpha into sigma by root n. X bar plus r minus z alpha into sigma by root n. So sometimes we can write like this also. Okay, so like that, sometimes they will give sample standard deviation. So in that case, the confidence interval is x bar minus z alpha into s by root n, comma x bar plus z alpha into s by root n. Okay, s by root n. So and also that can be written as x bar plus r minus z alpha into s by root n. Okay, so this is the confidence interval for single mean. So what is the formula? The formula is x bar minus mu by sigma by root n, or z equal to x bar minus mu by s by root n. So this is the formula for test of hypothesis for single mean. So here we have to choose only single sample from the population. Okay, so now we will discuss about problems. So here we have first problem. The first problem is a sample of 400 items whose standard deviation is 10. Taken from the population, the mean of the sample is 40. Test whether the sample came from the population with mean 38 at level of significance 0.05. Also calculate the confidence interval for the single mean. Okay, so observe carefully the question. Here they have given that the sample of 400 items, that means they have given that the sample size, we know that sample size is denoted with small n. Okay, so here they have given that small n equal to 400, small n equal to 400, with whose standard deviation is 10. So here the standard deviation is nothing but, here they have given that the sample standard deviation. We know that the sample standard deviation is denoted with S. Okay, so here the S value is 10. Okay, so from the population, the mean of sample is 40. So population mean. So population mean is denoted with mu, and the mean of sample is, so here the population, so here if they have given that from the population and the mean of the sample is 40. So here they have given that mean of the sample is denoted with x bar, right? Mean of the sample is denoted with x bar. So here they have given that x bar equal to 40. And test, what is our question here? Our question is test whether the sample came from the population with mean is 38. We know that population mean is denoted with mu. Okay, so population mean is denoted with mu. So here they have given that mu equal to 38 at level of significance. Level of significance is denoted with alpha. So here they have given that alpha value is 0.05. That alpha value is 0.05. So also calculate the confidence interval for the single mean. The confidence interval for the single mean. Okay, so here we need to calculate the confidence interval for single mean also. So before going to start this problem, first of all we need to write all the values. So here they have given that n equal to 400 and s equal to 10, and x bar is 40, and mu equal to 38. So mu equal to 38, and also alpha equal to 0.05. So here we need to calculate. So what is our question? Test whether the sample is came from the same population with mean. Okay, so here our question is test whether the sample is came from the same population. Okay, so here the sample mean is 38. The continuation sentence is came from the population with mean is 38. So that's why here I am taking null hypothesis as mu equal to 38. So null hypothesis as mu equal to 38. Okay, so we have to follow those 5 steps. Okay, so we have to follow those 5 steps. What are those 5 steps? First one is null hypothesis, and second one is alternative hypothesis, and third one is level of significance, and fourth one is test statistic, and the fifth one is conclusion. Okay, so in that conclusion, modulus of z less than z alpha, we accept h naught. Okay, so in modulus of z greater than z alpha, we reject h naught, right? So this is our procedure. So we have to follow that procedure to do this problem. Okay, so here the null hypothesis. So here null hypothesis is denoted with h naught. Okay, so null hypothesis, our step 1 is null hypothesis. Always null hypothesis is denoted with h naught. Here I am taking h naught is given statement. So what is our given statement? Our given statement is mu equal to test whether the sample came from the population with mean 38. So that's why I am taking mu equal to 38. So we need to check whether that sample is came from the same population or not. So that's why mu equal to 38. Okay. So alternative hypothesis. So here I am taking mu not equal to 38. So mu not equal to 38 means, so that is a two-tailed test. Two-tailed test. Okay, so why we are taking mu not equal to 38? If you take, you can take mu greater than 38, mu less than 38, like that, right? So, but here there is no scope in given statement. So, before our given statement, sometimes they will mention at least, at most, like that. Okay, at least, at most, fewer, less than, greater than. So, like that they will mention. If that in at that case, if they mention less than means, so that means mu is less than 38, right? So our statement is mu less than 38, right? So at that case we have to take mu greater than 38. So mu greater than 38. Okay. So if mu is greater than 38, then you that is opposite to the null hypothesis, means alternative hypothesis will be mu greater than opposite. That's why that is less than 38. Okay. So in the question they will mention whether it is less than or greater than sometimes. Okay. So if they're not mentioned before the given statement, then directly you can take that is not equal to. So here the given statement is mu equal to 38 and alternative hypothesis denoted with H1. So here H1 is mu not equal to 38. So that means that is two-tailed test. Okay. So next one is third step, level of significance. So level of significance is, we know we have already this one. So that is alpha is 0.05. So alpha is 0.05. So we need to take alpha 0.05 at two-tailed test. Okay. So then Z alpha will be 1.96. Okay. Z alpha value 1.96. We have to take from the table. I will show you after this problem. Okay. So how to take Z alpha value from the table. Okay. So here alpha is 0.05. So in two-tailed test, we have to take Z alpha value is 1.96. So here we are taking Z alpha value at 5% level of significance, right? So we are taking level of significance. Okay. So here we are taking level of significance alpha value. This is our alpha value. Alpha value is 0.05. That means alpha value 0.05 at two-tailed test. At two-tailed test is 1.96. So like that 5%. Alpha value is 5% or 0.95. And the confidence interval is here 95% or 0.95. So at this case, this case, alpha value is 0.05. In two-tailed test, Z alpha is 1.96. Okay. So like that, if alpha value is 0.05, in right-tailed test, Z alpha is 1.645. Okay. So alpha value is, alpha value is 0.05. In the left-tailed test, Z alpha is minus 1.645. Minus 1.645. Okay. So alpha value is 0.05. In two-tailed test is 1.96. Alpha value is 0.05 or 5%. In right-tailed test is Z alpha equal to 1.645. If alpha value is 5%, that is 0.05 at level of significance, at left-tailed test is Z alpha equal to minus 1.645. Okay. So level of significance, like that we can take alpha value is 0.05. So if alpha value is 0.05 in two-tailed test, so then Z alpha will be 1.96. Okay. So next step is test statistics. Okay. So here we need to write the formula. So but what is our formula here? So here they have given that n equal to 400, s equal to 10, x bar equal to 40 and mu equal to 38. So these values are suitable for only z equal to x bar minus mu by s by root 10, right? So x bar minus mu by s by root 10. Okay. So that's why here we need to write z equal to x bar minus mu by s by. So s by root 10. So that is equal to x bar. So we know that x bar is 40 and mu is 38 and s is 10 and n is 400. So substitute all these values here. X bar is 40, mu is 38, s is 10 and n value is 400. After simplification we will get 4, but we need mod z. If we have negative value, if z equal to minus 4, then also you need to take that is positive. That means here we need to take mod z value. Okay, so but here we are having 4. Okay, so that's why we need to take here mod z is 4. Okay, so coming to the conclusion. So we know that the conclusion is, so modulus of z less than z alpha, we accept h naught. Okay, so if modulus of z greater than z alpha, we may reject null hypothesis. Means, so here in the conclusion, mod z greater than z alpha. So what is actually mod z value? So here mod z value is 4 and z alpha is 1.96. So mod z is 4 and z alpha value is 1.96. So always 4 is greater than 1.96, right? 4 is greater than 1.96. That's why mod z is greater than z alpha. So if mod z is greater than z alpha, we reject the null hypothesis. So we reject the null hypothesis. That means the given statement is wrong statement. So what is our given statement? So the sample came from the population with mean is 38 is wrong statement. Okay, so the sample is not came from the population with mean 38. Okay, so that is our statement. Okay, so next we need to find the confidence interval for single mean. So now we need to find the confidence interval for single mean. So confidence interval for single mean is x bar minus z alpha into s by root n and x bar plus z alpha into s by root n. Okay, so here we have x bar value is 40, mu is 30, no need of mu. So x bar is 40 and s is 10, n is 400, and what about z alpha? So z alpha is 1.96. So substitute all these values. 40 minus 1.96 into 10 by root 400, comma 40 plus 1.96 into 10 by root 400. If you simplify this one, you will get 39.02 and 40.98. So this is the required solution. So next question is, an oceanographer wants to check whether the depth of the ocean in certain region is 57.4 fathoms and had previously recorded. What can he conclude that at a level of significance 0.05? If the recordings taken 40 random locations, in the given region whose mean is 59.1 fathoms, with standard deviation is 5.2 fathoms. Okay, so observe carefully. The oceanographer wants to check whether the depth of the ocean is certain region. So that is 57.4. So that means here you need to take mu value as, that means population mean. The huge amount is nothing but population. So here they have given that the population mean is 57.4 and the level of significance alpha equal to 0.05. And the recordings taken from the 40 random locations, means here they have given that sample size. So sample size, that is nothing but n. So random locations, how many locations are there, what is the sample size for this one is 40. That's why, so n equal to 40 in the given region whose mean. So whose mean means that is sample mean. So sample mean is denoted with x bar. So here they have given that x bar equal to 59.1 and with standard deviation. What standard deviation? Sample standard deviation, this continuous sentence. Okay, so this is sample size. After that sample mean will come. After that continuation, sample standard will come. Okay, so sample standard deviation. So the sample standard deviation is denoted with s. So here they have given that n equal to 40, s equal to 5.2, x bar equal to 59.1 and mu equal to 57.4. Okay, so now we need to follow the 5 steps. What are those 5 steps? The first one is null hypothesis, and second one is alternative hypothesis, and third one is level of significance, and fourth one is test statistic, and fifth one is conclusion. Okay, so here we can conclude whether the given statement is we are going to accept or reject. Okay, so first we need to find a null hypothesis. Null hypothesis is nothing but H naught. So H naught is nothing but our given statement. So here our given statement is this one, 57.4. Okay, so that means mu equal to 57.4, and the alternative hypothesis opposite to the null hypothesis, so that's why that is mu not equal to 57.4. Okay, so this is a two-tailed test. So already we have discussed in the previous problem. So mu not equal to, so alternative hypothesis is nothing but given statement, and null hypothesis is nothing but given statement, and alternative hypothesis is nothing but opposite to the null hypothesis. Differs from the null hypothesis, alternative hypothesis. That's why we need to take mu not equal to 57.4. And third one is level of significance. So level of significance is denoted with alpha, and alpha equal to 0.05, and Z alpha will be, so what is Z alpha value? If alpha equal to 0.05 in two-tailed test, Z alpha alpha is 0.05 in two-tailed test is Z alpha equal to 1.96. Next step is fourth step. Our fourth step is the test statistics. So here we need to write the formula. So what is that formula? Z equal to x bar minus mu by s by root n. So that is suitable for these all values. Okay, so Z equal to x bar minus mu by s by root n. So substitute all those values here. So here x bar equal to, so what is x bar value? X bar is 59.1. So 59.11, what is mu value? So that is mu value is 57.4. So divided by S. What is S value? So S is 5.2. So S is 5.2 divided by under root of, so what is N value? So N is 40. So observe carefully, these are large samples, right? So why we are saying those are large samples? If N is greater than or equal to 30, we can say that that is large sample. If N is less than 30, that is a small sample. So observe carefully, here N value is greater than or equal to 30. So in previous problem also, N is greater than or equal to 30. So N is greater than or equal to 30. That's why we can say that that is a large sample. So these are all large sample tests. Okay, so first you check the N value. Okay, so now substitute all these values here. After completion of this one, we will get 2.06. But we need mod Z now, so that's why modulus of Z is also same, right? 0.26. Okay, so here mod Z is 2.06 and Z alpha is 1.96. What is the conclusion here? So mod Z is 2.06. Mod Z is 2.06 and Z alpha is 1.96. So is mod Z is less than Z alpha or greater than Z alpha? So mod Z is 2.06 and Z alpha is 1.96. So always 2.06 is greater than 1.96, right? So 2.06 is greater than 1.96. That's why, so mod Z greater than Z alpha, mod Z greater than Z alpha. So that means this is calculated value and this is tabulated value. So here we are having calculated value. Calculated value is greater than the tabulated value, table value. So that's why we reject in H naught. We reject our statement. So our statement is, given statement is wrong statement. So he need to check the depth of the ocean in certain region is 57.4. So this is our wrong statement, right? Because we reject our statement. That means we reject a null hypothesis. That means our statement, that is our wrong statement. Okay, given statement is wrong statement. That like that we can conclude. Thank you.